Hi, welcome to our session. My name is Scott Glaser, and I'm here with my coworker Prakash Ramesh, and we're here to talk about a culture of resiliency through chaos. So let me start by telling you a little bit of story. On January 15th, 2009, there was a flight number 1549, that was flying from New York City to Charlotte, North Carolina. And the plane was taking off, and as the plane took off, shortly after it got into flight, about half a mile elevation, it hit a flock of birds, and both engines in the plane went out from the birds hitting the plane. These were like large birds, Canadian geese. And what happened when that happened, and the plane lost both engines and was starting to glide, the pilots reacted right away. They tried to go back to the airport and land to another airport, but they weren't able to because of they were losing elevation. So they reacted very quickly, and through the experience of the pilots and through the procedures they followed, they were able to land the plane in the Hudson River. And that whole situation, of the 155 passengers, no one was hurt. In fact, the National Transport Safety Board said it was the most successful ditching of an aviation plane in aviation history. So how does all this story relate to resiliency and chaos? So what this means is that things are going to happen. Unpredictable things that you're not going to know are going to happen. And it really comes to how you react and how you recover and learn from that. So in the situation of the story I told you about the plane flight, is you can't predict that every time you take off from an airport, you're going to hit a flock of birds and what's going to happen. So that's very chaotic. You don't know those kind of things are going to happen. So when those things happen, how do you react to that? And how do you have some sort of way of dealing with it and learning and recovering from it very quickly? So that's how the story kind of relates to what we're going to talk to you about next in a technical perspective. So what ends up happening when you go through these things, you tend to fall back on what you know and how you work in your workplace, which is really an evolution of your culture. So what we're going to talk about and continue in more detail is how this chaos, unpredictability, and chaos engineering affects what you deliver and how you improve your products. We're going to look at how to use observability and how you become more resilient by looking at these things. So in the process, we're going to introduce some random unpredictable behaviors and for you to identify some weaknesses in your product, and how would you recover from those, and the main goal here, one of the main goals, is not only learning from that, but also how quickly can you recover from those kind of things? Because one of the things you want to really practice on is your mean time to recover. All right, so next I'm going to hand it off to Prakash, and he'll take you on to the next steps.
Thank you, Scott. Hello, everyone. My name is Prakash, who will be talking for the quick chaos demo. Now let's see the methodology we adopt to conduct a chaos. First, we define a steady state and plan for chaos. Orchestrate chaos, which can be as simple as a failure, which we will see later in a demo, or it can be as complex as a multi-step failure scenario where more than one component can fail. Once we have identified and defined the chaos experiment, we plan it as a game day and constantly look for opportunities where we can make it as a game session and move it ahead in the DevOps lifecycle. During a game day or a game session, we create a chaos and observe the impact using the standard observability tools we have. We primarily look at golden signals like error rate, saturation of resources, response times, latency of the services and the system, so on and so forth, along with the alerts emitted by those tools. Once we have identified any resiliency failure, we fix and expand the scope in the next cycle of the chaos experiment. Also, before we ship any service or product, it's tested for standard set of resiliency experiments. That's how we mature and build a culture of resiliency. Now we will see where test for chaos. It can be done during any part of the DevOps lifecycle, during a CI/CD build, performance or load testing, functional or integration testing, in pre-prod or prod environment. The key thing we have identified based on our experience during our experiments is system behavior under load with chaos gives much more insights and helps us to identify the unknowns than a chaos test just conducted without any load. So real and challenging resiliency issues are observed under production-like load. Now, how we plan to test? It's a three-step approach where we define a workload profile which mimics production in lower environment. If chaos cannot be conducted in production-like environment for various reasons, we do it in the lower environment. Second step is to create a chaos using standard set of tools which are available in CNCF landscape or as simple as a script which you can in-house develop. One thing we take care when we conduct or choose a tool is it is multi-substrate, which allows us to conduct chaos across different cloud deployments we have. Third step is we use the observability tools across all the platform and the clouds which we have and look at the key golden signals based on the service and the system under test, along with alerts and infer resiliency improvements. We also enable shift left of the game day to create an on-demand game session using GitOps and Slack integration. Over a period of time, we build a maturity model by scoring each of the system and services for resiliency. That's how we plan and conduct a chaos and observe the results of the chaos. With that, let's jump into a quick demo. We would like to close this talk with a simple demo. In this demo, we are going to build a hypothesis around a simple scenario using Elasticsearch, which has a functional index and is deployed in Kubernetes cluster as a stateful set. We are going to query an index that returns some results using a load testing tool. While this happens, we are going to create a chaos by killing one of the pod in a 3 replica stateful set and see how it impacts the index and check if the index is designed to be highly available. Let's go ahead and start the test now. The green line here indicates success, the red indicates failures. So I'm going to kick off a new test, which is going to create a load and start querying the index. Now I'll let it run for some time before I create a chaos by killing the pod. Now to kill the pod, I'm going to use an API integration. Any script or a CNCF compliant or a landscape tool can be used to simulate this. And in this case, I'm just going to use an API integration. So the same API can be extended and integrated to any collaboration tools like Slack, where the game day can be really converted into a game session on demand by the developer themselves. Now I've kicked off the API, which is going to shut down one of the, or go ahead and kill one of the pods, which is deployed as a stateful set. And I'm using the Elastic monitoring to see the index state. So we can see that the index is getting queried and it's just having one replica. So that's the purpose of this demo, to see how it impacts and what is the action item we need to take in order to improve the high availability. In a bit, we are going to see one of these nodes go down while this query is successfully being run. So let's wait for some time and see how this impacts. Yep. Now we can see that the failures have started to climb, which indicates that there is a node failure as per our chaos created. So there is one single node which has gone down, and the query or the index does not have any available shards for it to return any results. So that's why we are seeing this index fail and our test cases fail as well. Now, in order to mitigate this in a real life scenario, as per this simple demo, we can definitely go ahead and increase the replica count, which will make the index highly available. We can see that the success have started and the failures have dropped right now. This is because of the nature of the stateful sets, which is designed to be self-resilient, and also the Kubernetes controller kicks in and makes sure that the specific pod which got killed is restored, which also restores the specific index available. So with this simple scenario in this demo, we can see how simulating a failure on a stateful set helps identify high availability on an index, while the stateful set itself by design is restored based on the Kubernetes controller. Thank you all for listening in. With this, we wish you a great rest of the Spinnaker summer. Thank you.